Hello, anatomy students. Welcome to the ear anatomy. So this is plate 97 or page 97 in your coloring book. If you could find that, there may be some things that we want to highlight, underline, make note of, etc. I'm very excited about today. Without the ear, you would just be watching me, and I would sound like this. I don't know what I just said there. That was totally made up. Obviously, we all know the ear is for hearing. And maybe you have an idea of how the ear works. It is an amazing organ. It really is an organ because it's a collection of tissues and a collection of different parts that help perform a function. And it actually has two functions. And so hearing is only half the story. The other half of the story is actually equilibrium. So if I turn my head sideways, I know that I'm sideways. I can sense that. And if I'm in an airplane, and that airplane, if I have my eyes closed and that airplane tips sideways, I know that it tips sideways. I have what's called equilibrium, and we'll talk about how that actually works. We have three axes, so if you think X, Y, and Z axis, we'll talk about that in just a moment. All right, so hopefully when we're done here today, you'll have a good idea, at least how you pronounce some of the terms, a basic idea of where the terms are, and then it'll be for you to sit down and more master the pieces and parts and whatnot. Now, this is the picture in your book, and this is all that you actually need to color. In your coloring book, there is actually, so I'll kind of hold it up here. There's a whole bunch more down here towards the bottom called the bony labyrinth, and then there's a little more this right over here. It's backwards for me. This over here. We're only worried about the big diagram, and I may actually print that off and make it larger for you. Some of the pieces and parts are awfully small, and they really are. And if you think about it, the ear that's in your book is probably a little larger than actual real life. Yeah, pretty close. Just looking at the outside of the ear here. Well, obviously on my screen it looks bigger to me. But anyhow, it's pretty similar though. So some of these bones are really small, and these are going to be our last six. Actually, there is one other bone. So we're going to have 6 bones. We've done 200. We've actually done 199 bones. When we're done with the ear, we'll have 205. Then I'm not going to tell you where the last bone is, at least the last name bone, but I'll give you a hint. We're not going to get to it until we get to the muscular system. And then whenever you figure out, Mr. Ackert, there's number 206, shoot me an email. Whoever the first one it is, or if you can figure out which bone we haven't done yet, shoot me an email. I'll buy a candy bar. And so if you can figure out what that 206th bone is. So anyhow, this is our diagram that we're looking at here. I do have a one that's already in color that I pulled from the web that I will use, but they're very, very similar in focus, or in the terminology, obviously. All right, so I'm going to go to that one really quickly here. And I'm just going to kind of work through the anatomy a little bit and about how our ear works slightly. Let me move me down here to the bottom because I'll be out of the road then. Somebody remind me to talk about cranial nerve number 8 when I get up here. Somebody holler. And so first let's talk about the outer ear. Okay, so in the pig we do, and I am very excited since we are going to be able to be in person 5 days a week, we will get to dissect the pig. Woohoo, fetal pig, here we come. We'll be doing that about the last month or so of school. I'm very excited about that, can you tell? I didn't get to do that last year, so I'm very excited that we can do that this year. So I would suppose that I think Rachel's in one of my classes. She's going to want to do the pig dissection with us, which, hey, no problem, Rachel, you can join in. She doesn't even know that I'm talking about her. You can tell her about that, Sierra. All right, so the outside of the ear here is the auricle. Okay, in the pig we'll learn it as the pinnae. You might say, well, it's just the ear. Well, yeah, but this is the auricle. Auricle, A-U-R-I-C-L-E. Okay, so it's the entire. And it has all these folds in it. You know this. I mean, some people get different ones of those pierced. It's mostly cartilage, and actually is elastic cartilage. When we talked about our cartilage, because when I do my ear, it like bends, flips right back. Whoa. Let me grab my pen tool here so it doesn't do that again. And so all these folds actually helps funnel the sound. And this is why if you like, I mean, you can make your hearing better. I mean, literally, if you do this and you listen to me, even listen to myself, it sounds a little different. And you listen to yourself talk is a strange thing because you're you're getting sound two different ways. When you speak, you're actually getting the vibration through your body and into your ears, but it's also going out your mouth and back in your ears. So listening to yourself talk is really, I mean, you can do this if you plug your ears, if you like put things in the outside of your ears and you talk, I really sound strange. And I can almost feel like I'm hearing that sound come from my throat, the vibrations going up into my ears. And it's why when you have like a sinus infection and your nose is all plugged, you sound strange, and you do sound strange to others as well, because a lot of our sound actually comes the timbre of our voice comes from the resonance inside of all of our sinuses. So anyhow, before I get off the rails too much, let's talk about sound. So sound waves, okay? Sound waves are compressional waves. When I clap, what I did is I squeezed the air and it went out to the microphone that's right up here, okay? And it picked that up. In fact, in my microphone, there is a little membrane that actually can vibrate. Now it's a little different in computer because it's sensing the sound a little differently, um, kind of changing it into electrical impulse. But I get these compressional waves, and they're not the traditional kind of wave we think of waves that are like this. This really is the air is compressed together. So when I clapped, I get this big, huge compressional wave right here. And if I clap again, there's another compressional wave. And so we can think of sound as being these little packets of air that's squeezed together. So those enter into our ear and they travel down. Now, if this was the skull, we would know this is the exterior auditory meatus. And so they call it, in this one, they call it external acoustic meatus. Auditory is the same as acoustics. You might know it as the ear canal, but please note in your term, in our book, it does exterior auditory meatus. And this is where you're not really supposed to put Q-tips down. You're really not supposed to. If you use Q-tips, you're really only supposed to like just clean the outside of your ear. You're never actually supposed to put Q-tips down into your ear. I'm guilty, I'll be honest. Because what happens is the earwax that's building up in here, so if you have earwax that's building up in here, you're actually pushing it further and you might actually press it up against this. You might even put that Q-tip in far enough to rupture what's called the tympanic membrane. The tympanic membrane, you learned, or you've heard of it better as the eardrum. You cannot call it the eardrum. You must call it the tympanic membrane. And so as those sound waves are entering, so those sound waves are entering in, they hit this and they make it vibrate back and forth. So this is vibrating. That's terrible. Let me clear my space here a little bit. So this, the tympanic membrane, is going to vibrate based on the speed of those not the speed, but the frequency of those waves. Now, as it turns out, I'll give you a preview. So if I clap really soft, that's a really quiet clap. What happens is those sound waves, they were compressed, but they weren't compressed like the magnitude of the compression or the pressure wasn't as great. Now, if I clap loudly, prepare yourself. When I did that, I compressed the waves together the same rate, the same speed, but the pressure was much greater. So when the pressure gets here, that's how we hear sound. That's how we hear, like loudness is the pressure of the waves. The frequency, so if I talk really low like this, those waves are spread way out like this. Why did I have a southern accent? I don't know. If I talk like this, then those waves were very close together. That's the amplitude, that's the actual frequency. So if the frequency is higher and this vibrates back and forth more quickly, we recognize that as a higher pitch. Okay, so now this is vibrating. Now, all of this was what was really referred to as the outer ear. So technically the outer ear kind of ends, you see down here the three different regions of the ear. The outer ear is really the place where it might be safe to put a Q-tip. Let's think of it that way. Then we get to the middle ear. I've traditionally learned the middle ear as being everything past the tympanic membrane, and that could be the absolute like designation. Just happens to be in this drawing, it's a little different. Then we get to the inner ear, and it is actually still air. There's not fluid there. And so then we have three bones. These are what's called the auricle bones. We're going to learn the specific names. So this first one we come to, and in your book, this is label D. So this is, I think they do them D. Is it D, E, and F? It is. So D, E, and that's really, and then F that we have here. We have the malleus, which is actually means hammer. So that's hitting this next one called the incus. Incus is Latin for anvil. because in blacksmiths they would hit the anvil. That was what they would hit to, like the blacksmith would be uh, flattening out the metal that he was shaping. So we have the malleus, the incus, the hammer or the mallet, and the incus, the anvil. And then we get this bone called the stapes. And it is pronounced stapes, S-T-A-P-E-S. Now the stapes is sometimes called the stirrup. Now the reason for the stirrup, and unfortunately I don't know that I can make this any bigger, not very well. If you look at that and you know a stirrup that you would, like if you're riding horses, you can put your feet into that stirrup. Here's maybe a little better view of it. In this next one, here is that stapes. Kind of reminds me of a staple, and stapes is a little bit spelled like staple, if that maybe helps. But the stapes is then vibrating and touching this little part right here. Now your book has it, this one doesn't, but it's called the oval window. I mean, it's back behind the stapes. There are going to be two different windows we'll talk about, and what those are going to be. So we have this portion right here called the vestibule. So the vestibule, which in your book is letter I. Okay, it's this part, and if you actually, this kind of looks like a snail. This whole thing, part of it is the cochlea. So this whole thing right here, the purple, that's kind of the workings of our ear. This portion right here is called the vestibule. Now, the vestibule has two windows. Now, these are not actual windows. They're not made of glass, but they're a very thin membrane that can have some give. The inside of this ear, the vestibule and the cochlea here, are actually fluid filled. Whenever our ears, when we're hearing that sound, and this is vibrating because the malleus hits the anvil makes the stapes vibrate. This starts vibrating against that window. Think of it like a really level of saran wrap. And so it's pushing in and out and starting to vibrate the fluid that's inside the ear. So when this pushes in, so a very, very small amount, when this pushes in because of getting all hit, remember when my ear vibrates, this is moving in and out. Okay, so this stapes is moving in and out. That causes that oval window to kind of move in and out and causes pressure. Now, because we want to maintain a constant pressure inside our ears with the fluids, when this moves in, so when the oval window pushes in, to maintain a nice equal balance, this portion right here called the round window, and it really is round, would move out just a little bit. It just bulges out just a little bit. So when this moves in, this moves out. When this pulls out, and because remember it's vibrating in and out, then this would go the opposite direction. So the oval window goes in, the round window would come out. If the oval window comes out, it's pulled out a little bit, then this would go in. It's maintaining an equal pressure inside. Because these pressure waves, so we have this vestibule, because those pressure waves will send off to the cochlea, and the cochlea, and there will actually be a video later, we'll talk about how those work, but the cochlea is full of little hairs. And those little hairs all have different lengths. And different frequencies will make those hairs vibrate differently. It's a little bit like a piano. When they have 88 keys on there, each one has a little bit different pitch. You have millions of different colors, different length hairs. It'd be like having a piano that has a million different keys, and every sound frequency makes a different one of those keys vibrate. And that's where we hear sound. And if we push 10 of those keys down at one time, 10 different frequencies, 10 different hairs inside the ear will vibrate. Well, so now we are here, so this is cochlea, okay, and here's that vestibule. Now let me take a step back. No, actually, I'll continue on with my discussion of the cochlea here. So the cochlea have those ears now, then those messages will get sent out what's called the cochlear nerve. The cochlear nerve, and you can see that one in our thing here. So here was the cochlea. Here is the cochlear branch. Now, the one I have called the cochlear nerve, because branches are eventually going to combine. And we'll see why in just a moment. Somebody get ready to remind me of what I told you earlier. So let me take a step back. Auricle, external auditory meatus. Then it's going to hit the tympanic membrane. The malleus, the incus, and the stapes are going to vibrate based on, one hits the next, and the next one causes the next one. That sound wave gets transmitted into the inner ear. Okay, this inner ear portion, which is mostly made of the vestibule and the cochlea. And so those sound waves will eventually get sent down to the cochlear nerve, to our brain. Okay. Now, off to the vestibule are these little tubes running off to the top. And I'm going to come back to this purple one because here are three different, okay, and they are referred to as the semicircular canals. Now, why semicircular? Well, because they're kind of half a circle. They are also fluid filled and they run in different directions. And I actually have a model that I'll bring around that I made of this, of the cochlea. I was actually pretty proud of my model. But these run in the different axes. So X, Y, and Z. Remember when I tilt my head sideways or forward or back? It's all because the fluid inside of these are rotating. And if you spin around really, really, really fast, okay, and then you stop spinning, that fluid actually keeps spinning as well. And that's what makes you feel dizzy because the fluid inside your ear is still rotating around. So that fluid is open to the vestibule to the three different canals. And so depending on how you're spinning will depend on which of these canals kind of keeps the fluid keeps rotating a little bit. All right, now it gives you that sense of being dizzy. Now all of that message is sent through this nerve right here. Okay, and this is the vestibule because it's called the vestibular branch. And then notice how those come together. And so these nerves will eventually come together. So here's our vestibular branch, and this comes off here. And here's the cochlear branch, and eventually they're going to merge and head off to the brain. That makes what's called cranial nerve number 8. Yes, there are 1 through 7, and we're not going to get too crazy into those different cranial nerves. Go off to perhaps your RN nursing. You will have to kind of memorize each of those nerves and where they go. But sometimes it's referred to as the auditory nerve, cranial nerve number 8, and that is Z actually in your book. So this plate actually, if we did all of the labeling, would go all the way to Z, so 26 parts. Now let me take a step back just a moment and talk about something I missed in this middle ear. Remember, this says this is air, okay? Well, there is also some drainage that needs to happen here if there would be any kind of fluid buildup. But we actually have this tube right here called the auditory tube. This will eventually lead to the nasopharynx, which is the fancy word for throat. So this plays an important part in kind of maintaining the inside of your ear and the outside of your ear equal pressures. So, and I'll talk about that in person. I think I have a future video that talks about, but let's just suppose that we are in an airplane. And if you've ever flown in an airplane, you realize that when you go up in the air, your ears have to pop. This can even happen in elevators, or if you're driving up in the mountains, this can happen. Because let's suppose, so right now, let's suppose that, let me use this. So we measure pressure in millimeters of mercury. So let's suppose that normal atmospheric pressure is 760 millimeters of mercury. So let's just say 760 is the pressure outside the ear. Well, that would be the same as the pressure inside the ear. Now, as we start going up in mountains, actually, as we turns out, if we go up in mountains or if we're in an airplane, as we gain altitude, the pressure will lessen. So let's suppose now we're up inside the mountain, and let's suppose it's only 700, and it's probably an exaggeration actually, but let's suppose the pressure is 700. The pressure is still 760 in your inner ear. So what happens is the pressure pushes out on your tympanic membrane, and your ear hurts. You feel that pressure. So what do you do? What are you recommended to do? Well, the recommendation is chew some gum, swallow, talk to somebody, because what will happen is the pressure that's building up in here will leave through this eustachian tube. And that was what you'll hear your ear pop. When your ear pops, this pressure now is 700, just like inside, or less like outside the ear. And so this eustachian tube is very important in the maintaining of that pressure. And then the opposite happens whenever we're landing. When we land, so let's suppose we're up in the airplane and the pressure is 700 here, okay, and we're way up in altitude, and so it's 700 here, okay, because we're up at high altitude, it's low pressure, and we don't feel anything. So we start lowering, so we start going down the airplane, and so now we get down to ground level, and it's back to, let's say, 760 of those millimeters of mercury. Well, now which way is the eardrum pushing? Well, the pressure is greater inside, so it's pushing this direction. So you feel that pain. And so now what has to happen? You're chewing that gum, or you're talking, or you swallow. That actually causes this pressure to flow into, flow into this eustachian tube through your throat and your mouth, and this becomes 760. and your ear pops again, and it maintains that pressure. One of the more painful things that's ever happened to me in my life, when I flew back from Alaska a few years ago, I had a sinus infection. And that sinus infection caused my eustachian tubes to swell up with mucus. So when I flew, this could not level out. And it didn't matter what I did, I could not. And so it felt literally like somebody was stabbing my eardrum because that pressure would not normalize. Ugh, do not fly with a sinus infection. It is not a good thing. Get some good meds before you get on that airplane to try to break up that mucus that you might have in here. So that's my story about flying with a sinus infection. I believe at least it was self-diagnosed sinus infection. Never went to the doc before it kind of cleared up on its own. So that's a pretty good start on the anatomy and kind of how our ears work. And do keep that oval window and the round window straight. And kind of I talked about the function of those. We'll see that a little bit later in a video. It will talk about the round window and the oval window. So yeah, I think you're ready to move on. Now, you do not have to color this if you don't want to. You can if you want. The parts are pretty small, but it really is up to you how you want to do that. They do call that auditory tube, sometimes called the eustachian tube. This is also where some kids have to get tubes in their ears. There could be one of you that had to have tubes implanted early in your life, and so they actually have to put these tubes in because sometimes you're prone to infections or they're just not big enough. So anyhow, all right, so that's the ear. Have at it. There are some purpose games and Quizlet attached to this assignment where you're watching this. Please, I kept those together for this assignment. Please go off and master those. Then there's a formative assignment. Yeah, if you have any questions, let me know. And hopefully this is helpful in the anatomy and a little bit of the physiology, how it works, of the ear. All right, thanks for watching, and I will see you next time.